Okay, so I'm going to go through and make an answer key for worksheet 8 for Polarity. I'm going to do each individual problem as one short video, so you don't have to watch the whole thing. You can only watch the ones you think you need help with. And hopefully this will be helpful as you prepare for your quiz, which is going to be on Wednesday. So in the first structure, you have CCl4. So we're going to go ahead and calculate the number of valence electrons. So I'm going to do that over here. So I've got carbon and I've got chlorine. Oops. There's one carbon times 4 valence electrons. So that's 4 valence electrons. 4 chlorines times 7 valence electrons. So that's 28 valence electrons. So that's 32 valence electrons. So the next thing I'm going to do is I'm going to take my carbon, put it in the middle. I'm going to bond my chlorines to it. With single bonds. And at that point, I've used 2, 4, 6, 8. So that leaves me with 24 valence electrons. So I'm going to add dots in pairs until I've used all remaining 24. So I've used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. The next thing I'm going to do is identify the bond polarity in between the carbon and the chlorine. So in this case, I'm looking at carbon versus chlorine. I see that I have an electronegativity for carbon to be 2.5, and for chlorine, according to the periodic table, is 3.0. We subtract those and we get 0.5, so that is a polar bond. And it's going to be a polar covalent bond, but polar bond nonetheless. And if it's a polar bond, we have to draw a dipole arrow. We always draw our dipole arrow toward the more electronegative atom. So that would look something like this. And then we have to use our dipole or our partial charges. So the side with the more electronegative element is going to be partially negative. The side with the less electronegative element is going to be partially positive. So delta negative, delta negative, delta negative, delta negative, and then this carbon would be delta positive. The geometry here, there is one central atom. There are 4 atoms bonded to the central atom, and there are no unshared pairs of electrons on the central atom, so that's an AX4E. So if I go back up here, right, I see that I have a lot of structures. So each of these that have been given to me is kind of designed to help a little bit, like look at the picture and try to match it up. So in terms of CCl4, right, there's a central atom, and every single one of these structures has a central atom. It's the purple thing. It's the purple sphere. And then in the case of linear, there are 2 things bonded to the central atom. In the case of bent, there are 2 things bonded to the central atom plus the unshared pair of electrons. In the case of trigonal planar, there are 3 things bonded to the central atom. In the case of trigonal pyramidal, there are 3 things bonded to the central atom plus the unshared pair of electrons on the central atom. In the case of tetrahedral, there are 4 things bonded to the central atom and no unshared pair of electrons on the central atom. So that matches up there. So that tells me that the VSEPR geometry is going to be tetrahedral. Now, the last thing we have to do is identify if this is a polar or a nonpolar molecule. And in this case here, one of the things I'm going to be able to tell you is it's going to be a nonpolar molecule. It's a nonpolar molecule because the dipole arrows going from left to right are in opposite directions, so they cancel each other out. And the dipole arrows going up and down are in opposite directions, so they cancel each other out. So we can simply say that all of the dipole arrows cancel each other out. So that's how we draw the structure, identify the bond polarity, identify the VSEPR geometry shape, and then lastly, identify and explain how the molecule, what the polarity of the molecule is. So if you have any questions, let us know. Otherwise, I'm going to move on and do question number 2 next.